Hello, everybody, and welcome to the APAC Bricsys Summit, Australia and New Zealand edition. My name is Claire Lee Florentino, Technical Consultant for Bricsys in this region. If you missed our Global Summit in October, don't worry. We will be covering all the key topics for the session today. There are external speakers who can also give you a better perspective on how BricsCAD is ready to shape a digital tomorrow. V21 is one of our key launches. We have enhanced our 2D automation and 3D modeling capabilities with AI-based parameterization features, applications like Twinmotion and Civil Design. There are also many more exciting features that we can't wait to show you. So, hold your breath, we have a jam-packed agenda for this afternoon. Let's kick off. I would like to invite our VP APAC, Chris Lee, to share our Bricsys vision for this year.
Good day, everyone. We would like to welcome you to Bricsys APAC headquarters in Singapore. We are delighted to join many of our customers and partner at Bricsys Digital Summit for Australia and New Zealand today. At Bricsys, we deliver on the promise of DWG. Our customers and technology matter at Bricsys. We are a global provider of computer-aided design technology with advanced AI-based features for building information modeling, mechanical design, all supported by Bricsys 247, a SaaS-based common data environment platform. Over 400,000 of our customers across manufacturing, AEC industry have trusted Bricsys. Since 2018, Bricsys is part of Hexagon, a global leader in digital solution. BricsCAD is always ready for production. With the launch of BricsCAD V21, we have built upon our proven technology, boasting our innovation in reality capture technology, which allow our customers to achieve rapid point cloud to 3D model and visualization capability. Through our comprehensive 2D, 3D, BIM, mechanical design, and collaboration platform, Bricsys aim to bring our customers forward and be ready for the future. At Bricsys, we recognize there's no time for status quo. That's why we emphasize on continuous product development and innovation. BricsCAD is always ready for open collaboration. This is why we don't limit our client to proprietary format, and that's why we support native RVT and DGN, in addition to DWG with customized mechanical and civil 3D in our latest V21 release. To improve open collaboration in product data management, we will extend support for board and project-wise. In another area of immersive visualization, Bricsys has expanded our collaboration with Enscape and Twinmotion to achieve real-time visualization. And today, I'm pleased to announce that all BricsCAD customers can enjoy free perpetual license of Twinmotion till June 30th this year. In the area of numerical analysis and engineering application, we have developed a comprehensive network of partners through our established API and SDK to support third-party applications such as Grasshopper and MSC Cradle CFD. In enhancing our digital construction solution, you will hear more about BricsCAD integration with Leica Geosystems, world-leading positioning and high-definition surveying technology. This will deliver an end-to-end experience for scan to BIM, helping our customers to achieve BIM to field and field to BIM together with our Leica construction technology. BricsCAD is now available globally. We don't limit our customer to just one option too. We offer both perpetual and subscription option. Customer can continue to enjoy the benefit of network licensing and scale their operation with non-NIM user. Our customers are supported by a global network of Bricsys channel partner and third-party application developer. Through this comprehensive network of commercial centers, we are now able to bring the benefit of BricsCAD closer to you. Through today's journey, you will join our list of distinguished customers to witness Bricsys technology, and how we bring more values to you and experience the real benefits of DWG. As said, at Bricsys, we believe in the future of DWG. Let me now introduce you to Omar, our Regional Director for Australia and New Zealand, to take you through today's journey and bring forward the experience of Bricsys Digital Summit. Thank you.
So thank you, Chris, and good afternoon, everyone. Again, welcome to the Bricsys Digital Summit for Australia and New Zealand. Wow, that's a handsome likeness. So my name's Omar Auni, and I'm the Regional Director for Bricsys, based here in Sydney. And I want to thank you all for taking the time to not only see what BricsCAD has to offer in terms of functionality and so on, but I also hope you'll see and learn more about just what is possible in the arena of design tools. Now, most of you know that a couple of years ago, Bricsys was acquired by Hexagon. And as Chris just mentioned, Hexagon is one of the world's leading players in high-end technologies. Okay? They have over 20,000 staff worldwide. And since the acquisition of Bricsys, we've been able to accelerate the development of BricsCAD to bring you some fantastic new functionality, including the unique use of machine learning. And I say it's unique because you don't need to program anything to see results, as you might with other systems. And it's not just for creating high-end, mathematically defined shapes that you might use once in a blue moon either. It's right there, as it should be, helping you save hours on the mundane tasks that you might already do day in and day out. So I guess part of the testament to the value BricsCAD has is that last year, both globally, but especially here in Australia and New Zealand, and despite the turmoil that we all went through last year, and some are still going through, we had a record year of growth. And through it all, we've been hiring as fast as we can, and we've added around 20 people across APAC alone to better serve you and be more involved in your business. In fact, today is a bit of a special day for me because it marks exactly 3 months since I joined Bricsys. And I have to say, not a day goes by when I'm not absolutely amazed by the very talented people I get to work with and by the amazing solutions that we offer customers, both in functionality and tangible financial benefits for the owners of those businesses. Now, I understand that changing your core tools can be daunting. And like most business decisions, how that change will impact your profits and risks to your business needs to be carefully considered. I'm fairly certain, though, that this summit will provide you with the confidence that BricsCAD can help you design better, remain more profitable, and reduce the risks to your business. So let's first kick off with an introduction to the BricsCAD product family. At Bricsys, we made it simple for customers to choose what they need. We have 2 products in what we call our core tools and 2 specialized offerings as well. It's a family of tools that punches well above its weight in terms of capability, flexibility, and value. They're easy to implement. They have the most flexible licensing options of almost any software, really, and the best value in pricing. And with all that, they also have some delightfully powerful features, including those that use machine learning. And we'll talk about those and see them in action later. So BricsCAD will allow you to design pretty much anything, all within the one familiar interface and using the one incredibly powerful file format. In fact, we managed to achieve the most advanced use of the DWG file format. And again, we'll show you some of that later on. But imagine for a moment if you had to modernize an old complex chemical processing plant. Now, you could scan the entire facility using Leica Geosystems' incredible next generation tools, for example, and then bring that huge point cloud that you'd end up with straight into BricsCAD and very quickly generate a terrain model or BIM model of the building and facilities and so on, all within the same DWG file format. Now, engineers can go and do the plant design, modifications, ISOs, PNIDs, layouts, everything else. Architects can go and design the building along with their MEP friends. The design can be conceptualized, it can be visualized, documented, all within the one file format. So you can even use the same file format, I should say, to put the whole thing into one of Hexagon's amazing tools that allow you to manage and maintain the plant once it's handed over to the owners. Now imagine that. No file conversions, no loss of data, no arguing about where things were missed or dropped. Right? We've gone miles ahead of all the others in terms of what we can do with the DWG file. Now, of course, we can also import and export many formats. So you can work with those, let's call them less fortunate than you, if you must. I say that with tongue in cheek, of course. Now, if you simply need drafting tools with the ability to run Lisp routines, then BricsCAD Lite is the tool for you. It's very rare to see a low-cost drafting tool that gives you this level of automation. BricsCAD Pro offers powerful 2D and 3D design functionality, including powerful surfacing, solids, modeling, and visualization tools. And it runs a vast array of third-party applications as well. For those of you who are familiar with our old BricsCAD Platinum product, then all of that functionality is included in Pro as well. Next, for those who need to design mechanical assemblies, complex parametric designs for manufacturing or product development and so on, then BricsCAD Mechanical will be the one that gives you unprecedented level of power and control over your designs. And then we have BricsCAD BIM for those involved in the AEC space. Architects and building designers can go from concept to design documentation faster than ever and without the typical without the restraints, I should say, of typical BIM design tools. Engineers can work on the civil and MEP side of things in the same file format, and that makes coordination much easier and faster than ever. And while some builders still prefer to work from 2D drawings, it means that they can stay in the same file format too. And they can use those connected 2D drawings that come out of the BIM model, for example. Now, all of these products, by the way, support multi-processor multi-threading. So loading several gigabytes of point cloud data, photogrammetry, or highly complex detailed mechanical models won't even make a dent in BricsCAD's performance. And again, you'll see that shortly. Now, of course, if you need to collaborate with external parties, then Bricsys 24/7 is our cloud-based common data environment or CDE that's deceptively easy to use and set up, but it's still very powerful for project teams. So let's have a look at those in a little more detail. Now, BricsCAD Lite, as I said, it's an entry-level drafting tool, but despite being entry-level, it still has a customizable interface. It has machine learning functions like copy guided, which we'll show you as well. And it gives you the ability to use the full power of Lisp. Now, as I said, this ability to use Lisp in an entry-level drafting tool is almost unheard of. And I think you'll know what I mean there. BricsCAD Pro is for users who need it a bit more. It contains powerful 3D constraint engine, automatic parameterization. So you can work with tight parametric components and arrays, but then when it's coupled with the flexibility of our deformable 3D modeler, then the sky's the limit for realizing those designs that you can come up with. Of course, there's even more machine learning magic built into Pro, and we'll show you some more of those. So while there are over 400 third-party commercial applications built on our BRX API that runs on BricsCAD Pro, it also contains our civil workflow, which includes tin generation, gradings, and alignments, and so on. All of this in a core CAD product. That's pretty amazing. Next, we move on to BricsCAD Mechanical. And as I said, that delivers advanced mechanical assembly design tools in a familiar interface, again, all in DWG. So using powerful 3D constraints, automatic parameterization, Got to say that 3 times real quick. You can work your designs from the top down or from the bottom up. Next, we have BricsCAD BIM, and that offers you a comprehensive building design and documentation workflow that focuses on design first. So you can work in CAD accurate freeform solids and surfaces and so on without the rigid limitations of a family-based system. And whether your project requires a full BIM workflow or just some, basic drafting and so on, BricsCAD BIM will allow you to do both in the same interface and again in the same file format. BricsCAD BIM uses the power of DWGs and XREFs, I should say, to bring information modeling to everyone, from beginners to seasoned experts. And while we're on the subject of BIM, by the way, Bricsys, being a founding member of the Open BIM Alliance, helped write the rules on how to play nicely with others. And I mean that using IFCs, of course. And we've even turned BIM into a verb. So using machine learning, you now have the ability to BIMify your model, and that allows you to convert a solid model into a real-world BIM design. And it accurately classifies your design elements to the correct standards that you choose. Now, those of you who have tried this using other systems will know that it can take days to do this properly, and there will still almost certainly be quite a few errors, particularly in the classification side of things. Now, if you're anything like me and you spend time dabbling in designing things, everything from buildings, extensions to your house, machinery, a doghouse, or even wiring diagrams to convert your 1937 vintage lathe into a CNC-controlled antique. And yes, I am not ashamed to admit that that's one of my projects at the moment. Then come and talk to me about, or your reseller, about BricsCAD Ultimate, because that'll let you harness the power of all those editions of BricsCAD that I just spoke about for not much more money. Now, in our industries, no one is an island. So if you need to share your project information or collaborate with others on your projects, then Bricsys 24/7 gives you that powerful CDE that's very easy to learn and implement, just like a true cloud-based tool should be. You can self-learn how to use most of it in just an hour or two, and then reach out if you need help with the more advanced stuff. And at Bricsys now, we believe in getting computers to work for you, not the other way around. I'm sure you'll be relieved to hear that. And I mentioned that every edition of BricsCAD supports Lisp, and that significantly reduces, or can significantly reduce, the time it takes for you to do repetitive drafting or other design tasks. But it's not just your regular old boring Lisp. No. BricsCAD Lisp is based on OpenLisp, which has been benchmarked to perform anywhere from 5 to 100 times faster on the same routines than running in other CAD products. So applications or tools that might be written for AutoCAD and their runtime extension, ARX is the API there. They can be directly ported into BricsCAD, and in most cases, developers can build applications for both AutoCAD and BricsCAD using a single source code base. So this means any custom tools that you've already had developed should run just fine on BricsCAD, same as on any other CAD system, only much faster. So what does all this mean for you? Well, when you buy BricsCAD, you also become a member of an extensive user community. You're certainly not alone. There's a vast ecosystem built around the BricsCAD Runtime Extension, or BRX API, and we call that ecosystem the Bricsys Collective. And it features over 1,500 active applications, excuse me, with over 400 of them available free or for sale on the Bricsys application store, either at bricsys.com or directly from within BricsCAD itself. You can access the store. And BricsCAD offers integrated third-party workflows and tools for most designers. So whether you're designing in the AEC space, civil, infrastructure, electrical, mechanical, plant, structural, you name it, there are tools to help make you more productive and profitable We even have a New Zealand developer who has written a large irrigation system design tool, for huge farms and things like that, and it's sold globally. So do take a look at our app store at bricsys.com. And by the way, if you develop commercial applications or just even some internal tools for yourself, and you think you might like to share those or sell them perhaps, then come and talk to us. We have more than just a few customers who have commercialized their tools to create a new profit source or to simply offset the cost of development. So that's our product line. But before I finish up, I would like to share this little story from years ago when I was working in technical roles. I was asked by a very well-known EPCM company to conduct a skills audit of their CAD staff. Now, one lady who I remember very well was drawing an instrumentation drawing that involved one wire represented by a dash, then a circle to represent its line work. And I watched her draw a dash and then a circle and then another dash and yes, another circle again and again and again. And after sitting silently for a few minutes, I asked if there might be a better or more efficient way of doing this. And she said to me, quite excitedly, I might say, of course there is. I can select a dash and a circle and copy them multiple times wherever I need to place them. Now, of course, the answer I was looking for was a custom line type. Now, I tell you this story because it serves to demonstrate that people can be so engrossed in the now that they become very efficient at an inefficient or outdated task and don't even realize what's possible, rather than being focused on being effective in achieving their goal. So effective versus efficient. Think about that. One means doing things with less effort. The other one means achieving your goals. So please, as you watch the upcoming demonstrations by Sagar and the others, I urge you to look at how BricsCAD can help you not only be more efficient, but more importantly, be more effective. With that, I thank you, and I'll hand you over to Sagar. Goodbye.
Good afternoon, everyone. A warm welcome to all our customers. My name is Sagar Thorat, and I'm the technical lead for Bricsys Asia Pacific, a part of Hexagon PPM. In this session, we will show you the latest developments in BricsCAD Lite and Pro V21. With the latest version, we want to imagine unlimited design capabilities with BricsCAD. The core session has 6 exciting parts: changes to direct modeling, changes to parametric modeling, drawing optimization, SketchUp import and mesh editing, civil design tools, and point clouds. Let's begin this session with direct modeling. We have made enhancements to the direct modeling features. We have extended the fillet command by adding an option to set your fillet with a variable radius. The integrated manipulator allows you for quick editing of the geometry, and you can merge multiple fillets at various edges and angles. Further, we have enhanced the chamfer functionality by adding 5 new options. The DM chamfer command offers more flexibility with new asymmetrical, angular, variable symmetrical, variable asymmetrical, and variable angular modes. We will now try the 5 options on various edges of this part. While making your chamfers, you can set constant variable offsets for creating asymmetrical or symmetrical chamfers. In this case, we will use the manipulator tool to define the angle. In this case, 78 degrees. We will choose the variable symmetrical chamfer for this edge, and we will define 2 variable offsets on 2 edges. The next, we will choose an variable asymmetrical chamfer, and we shall apply two different offsets which will give us a skewed chamfer. The manipulator again is a handy tool to quickly manipulate edges. In this example, we will see that the move command previously had the connected elements follow the geometry that they were connected to. But now in V21, you can also observe the same behavior when you use the rotate command, and the connection still remains unless you disconnect those objects, and you can again use the rotation also to update these objects connected to each other. The L connect of BricsCAD is known to everyone as one of the most popular features. Now you can also disconnect the L connect and observe the behavior that individual objects can now be modified. Further, let's try the connected move and connected rotate on a complicated model. In this case, I would like to stress that this is not a building information model, but a parametrically connected 3D solids model. You see the roof, which we will manipulate with interior beams and connected walls. While rotating the roof, we make some calculations and define a value, and the roofs and the beams will follow along with the roof and update themselves. The connected walls also automatically extend, and we would like to stress on the point that this is not a BIM model, but a connected plain 3D solids model. Now here, we can also make changes when editing vertices. We can use the manipulator to move and edit surfaces. The default mode is set to triangulation, which will restrict the movement. Now we have added the option to be able to freely move the vertices to better edit the geometry. This gives you more freedom for your design. Now let's move to parametric modeling features in V21. Last year, we introduced a concept of geometry-driven constraints. This actually made it possible to select an angle or a distance in the model space and use it in expressions of other constraints. This year, we have taken a big step forward by making it possible to turn any parameter to a geometry-driven parameter. In this case, we will start with a plane model of the 3D chair. We use parameterize to automatically constrain this chair. The system has automatically created parameters to constrain this chair. It also automatically detected that the bottom part of the chair has equal dimensions. And we will now create a new size parameter and a back height parameter. So what is new here is that we can turn this size parameter of the value 750 to a geometry driven parameter, and simply by right clicking and selecting geometry driven, there is no value there, but now it's a geometry driven parameter. And now we can move any surface and you can see that it's geometrically driven and automatically the parameter will also update. In the same manner, we can also now, as a second step, we can select the parameter representing the back height of the chair and set it to be 2 times of the bottom part. As such, we can manipulate any face of the chair while our design intent is maintained accurately. Alright, now let's have a look at a more complicated structure for the geometrical driven constraints. Here, we have an assembly structure for a mechanical model which contains 5 nozzles. We can look at this small plate here, and we see that the parameters and constraint panels consist of a nozzle diameter and nozzle quantities. If you now change the nozzle diameter, the size of the plate changes accordingly. However, in V21, we allow to solve the inverse problem. If you now change the size of the plate, you can automatically compute the nozzle diameter and see them update in the 3D dimensional constraints. Let us have a look at another example of the geometry-driven parameter with the movement of this nut. In this assembly, we will choose for this particular nut assembly and isolate it. And we can now actually move this nut, which will be a simple translation. Simply move. Yeah. If you activate the angle parameter in the 3D constraints, the nut will now move with a rotational movement. Simply enable the angle and see the nut move in a rotational movement. How cool is that? Finally, I would like to note that the new features also work with models created using older versions of BricsCAD. For example, this complex pneumatic model with 6 actuator legs. In V21, we can turn all the driving parameters to be geometric parameters. And we can now freely start moving the upper plate of the model, and all the components in this assembly will move, and the system will automatically calculate the length of the legs. This is very exciting, and we can't wait to see how our users will use this new geometry-driven constraints with BricsCAD V21. At Bricsys, we are dedicated to deliver tools to help you create the most accurate data in the most compact forms, making your DWGs easy to use and lightweight to handle. New optimization tools in BricsCAD make use of AI and machine learning in order to organize the data in optimal forms. This roof truss assembly consists of almost 500 plain 3D solids. Let's have a look at one of these I-beams and use the parameterize command to automatically constrain it. In just a flash of the second, it has added these constraints automatically. We can now use the animate tool to visualize, associate each parameter with the modeled geometry dynamically and see the updates. Let us now introduce you to our new drawing optimization tool called Parametric Blockify. When we select the I-beam, it will convert the I-beam to a parametric block and also analyze the entire model and convert the similar solids to parametric versions of this I-beam. In just 7 seconds, we are done, and 213 of plain solids have been identified to be a parametric version of the I-beam. When we zoom into one of these beams, the property shows that the parameters where we can change the parameter, such as the length of the I-beam, the parametric bulkify provides our users with powerful and unlimited design capabilities. At Bricsys, we not only improve your 3D modeling and BIM capabilities, but our focus is also to improvise and constantly innovate the 2D workflow. We will now introduce the new drawing optimization tools. The first tool is a property called visibility states. As you can see, each of these chairs are composed of a 2D geometry, namely lines, arcs, and polylines. We can convert these entities into a block in just one click, and the geometry is converted to a new block reference. Let's now edit this block and launch the visibility states command. It's now possible to create a visibility parameter with 3 different states for each of these chairs. We will create one state. We will call the first one as simple. The second one, we will call it as comfy. And the third one, we will create and call it complex. For each of the types, now we have a state, and we will now have to move them on top of each other so that they are nicely stacked at the origin of the block editor. We can use the 0, 0, 0 as the point, as the common insertion point for all those three chairs. We are done. And after doing this, we are now ready to import this into our model space, nicely stacked on top of each other. And we will now check the properties with one of the type parameters with three states as we define them. And let's now perform some real magic using our new parametric chair block. We will launch the parametric blockify and select the chair to be the input of the command. The command will automatically analyze the entire space and replace sets of 2D geometry representing each type of the chairs by the parametric block. And we can select one or multiple chair blocks and replace them with one of the visibility states out of the three. We believe that parametric blocks is a very powerful new feature, and sky is the limit with BricsCAD V21. Let's have a look at our second optimization tool. We are into the drafting space now. Some drawings during the drafting or during the sequence import or export process will have some errors. It might also happen due to multiple file formats jumping onto each other while doing imports and exports. And how do you remove these inconsistencies in your drawing is by using our new optimize tool from the manage panel. And in the properties, we can see that the coordinates are not optimal. So we will launch the optimize tool, and we will first select all the entities to optimize, and we can see the several options that are available. We can choose to close gaps with tolerances. We can set angles, tolerances. We can choose to rectify horizontal, vertical, or diagonal lines. The live preview is updated accordingly, and we can see that the optimized drawing, the gaps are closed, and all the lines are nicely arranged on top of each other. Looking at the properties panel, we can see consistent Y values. Similarly, we can close gaps, larger gaps, by defining the gap tolerance. Let's try this on a much more complicated model. Now, here's a drawing that originates from a projection of a point cloud into a 2D plane. The lines here are not really horizontal nor vertical, with lots of gaps and inconsistent values. And now if you want to use a 3D snapping tool such as Quick Draw, you will not be able to accurately model. So what we will do, we will use the optimize tool. We can select the entire drawing and change some values, and we can see the selection set being optimized live in the live preview. And we are happy with the optimizing values. We can now see the lines being nice and horizontal. Most of the gaps are closed because we defined a larger value. Nice and clean straight lines, after which you can further optimize it or directly start using 3D modeling tools to begin your scan to BIM in 3D. So your cursor now snaps properly, and you can use the quick draw to quickly create walls and see it appear. Last year, we introduced the copy guided command. which allowed our users to select a detail in a context, for example, a door in a wall, to move it in a guided way to a specific location in the context of their design. So this year, we made a logical extension to copy guided and have launched a new command called move guided. It allows users to select a detail and move it in another location. And this command not only moves the detail but also heals the related entities at the original location. As you can see, the wall in the original location has been healed. In a standard drafting method, if you delete a door inside a wall and you create an opening in the wall, it will still remain. Whereas move guided, actually, you would regenerate and heal the original geometry in a very fast way. We will now use move guided at the exterior wall to delete some windows which is required as part of a design change. We can select the windows and move them away from the wall, after which we see that the wall has been nicely healed, retaining the original wall structure. With BricsCAD's AI family of tools like Blockify, Copy Guided, and Move Guided, we offer our users the best-in-class productive tools. We will begin this session by understanding the SketchUp import capabilities and mesh editing improvements in BricsCAD V21. We have significantly improved the performance of BricsCAD while importing files from other 3D modeling softwares by eliminating import downtimes. In this example, we will import a SketchUp file as a mesh. Importing SketchUp files is faster and more accurate. For BricsCAD V21, SketchUp entities are imported as named blocks, and render materials and textures are also imported. We at Bricsys want BricsCAD to be your geometry engine of choice. BricsCAD Pro V21 adds more than just new modeling features. Portions of our modeling core have been refactored to better utilize multi-threading wherever possible. We have made improvements in the way we handle meshes. There are now more mesh options in the properties panel. In the properties, we have added a mesh smoothness parameter where you can select the level of mesh detail for particular objects, including properties of mesh subentities such as faces, edges, and vertices. Here, we can work on an imported object, for example, changing a color of the geometry, editing the mesh line work and changing the level of detail, and editing points to deform the geometry is greatly possible. The improved display of mesh not only looks good, it also makes dimensioning and editing way easier, such as editing sub-entities like points, enabling you to do more and be more creative with your designs. In this case, we are now creating a blob kind of in geometry with local entity editing and creating this beautiful work of art using BricsCAD. With our new convert to solid command, you can now convert meshes directly to solids using this command. And post the conversion, the direct solids can be edited using our intuitive modeling tools. BricsCAD V21 brings new advanced tools for infrastructure modeling. Creation of tin surfaces is possible from multiple file types like CSVs and text files. You can assign raster images to tin surfaces to design in context
and use clipping planes to do so. We can then start defining alignments as objects used to precisely define the horizontal infrastructure. Alignments have horizontal, vertical, and 3D alignments. In V21, we have added supports for spirals and parabolas as well. By defining the horizontal alignments, we see that the vertical and 3D profile curves are automatically created using accuracy factors. We can now open the vertical profile editing view. We have now two alignments. Here, the cyan defines the existing ground and then the design profile, which also can be created automatically. We can then specify the accuracy factor to specify how closely the alignment fits to the existing ground profile. Then we can also switch to manual editing mode, where we can edit manually the profiles. We can remove and add PVI points and perform grip editing. We can see the radius, station, and elevation for each of the PVI points. In V21, we have added corridor functionality. We have first created the templates using simple polylines, after which we will attach the elements to the corridor templates. We can here have several templates in the drawing. We can attach multiple elements to the template. The templates can then be used to model the corridors. First, we select the 3D alignment and assign a particular template. The corridor will be developed as a real 3D geometry by specifying the start and the end station, and apply different templates for various segments of the overall alignment. If we select the corridor and switch to the properties, we can see for each region the start and the end station. We can switch on and off different graphical representations of the corridor entity. It's not limited to meshes. You can also look at frame structures with which the corridors are built. Now we shall develop the embankments of the corridor to define the cut and fill slopes with respect to the terrain. First, we can extract the edges of the corridor as polylines. Then we can use the polylines to create a grading and define the slope of the grading to create an embankment. Now we can modify the 3D alignment, and using grips, you can see that the corridor updates in real time. We can perform both horizontal and vertical changes to the PVI points. We can see that the tin surface is overlapping with the existing ground terrain, and now we can cut the required ground to fit our corridor and make it constructible by using tin surface editing tools. To hide the cut area, we can now visualize the road corridor design. We can merge different tin surfaces to create an overall tin surface and then edit the tin surface of the actual ground and hide the chopped boundary of the tin surface to make our road correctly visualized and not overlapped with the terrain. So in this case, I'm selecting the cut geometry, and by hiding the cut geometry, I will be able to visualize the real bridge after modifying the terrain correctly, which will also define your cut and fill quantities. Post the modifications, you can also add pillars, railings, and also parapets can be. Automation in point clouds has been one of the most awaited features of the V21.
The exciting new point cloud features for V21 include the import of E57 files in BricsCAD. We use three principles to develop the new point cloud features. In BricsCAD Pro, we want point clouds to be high performing, fast and easy to navigate up to 5 times. This is achieved by adding new file formats and including bubble views as part of the scan positions. We can attach and align point clouds to the global UCS. And secondly, for BIM users, we want to create 3D geometry with smart algorithms. The geometry follows the reality as it is, even if it is skewed, and we can identify the deviations in the model. Finally, we allow BIM users to create 2D floor plans, which is the coolest feature of V21. These 2D floor plans can be cropped and generated through volume sections. And these volume sections are used to generate these 2D drawings with the background raster image. The AI will automatically detect walls, and these parameters can be improved for the final results. We will launch the wall detect options, and we can either choose to have these in the same drawing or create a new drawing altogether. A lot of these performance improvements in point clouds were made using background processing and multi-threading, and we added a progress bar to give feedback to the users. We can now see in the final result, we get a high resolution raster image and lines which can further be optimized using the new optimize command to start developing a floor plan or a section. Further to these amazing features, we can now generate 3D geometry in BIM by accessing inside the bubble viewer, which opens a separate window which has 3 viewing modes. Here the blue is perpendicular to Z axis, red and green to the X and Y axis. To create the geometry, we can use the fit planar command. By selecting surfaces, you can detect rectangular shapes and contour shapes of walls, floors, and roofs. Fit planar is a great tool to fastly create the surfaces of walls, floors, and roofs, and further can be converted to actual 3D solids. Fit planar can also be used in the model viewer to work with all types of point clouds. The geometry created with fit planar can now be used to create 3D solids, such as in this case, we auto-detect the surface and define it to be a 3D solid of a certain thickness. And now we can hide the point cloud and see the output. And post this, you can use the standard direct 3D modeling features of BricsCAD to clean up this 3D geometry. With the combination of BIM workflows and the new V21 features, we can generate high-quality graphical images that can be annotated as normal BIM sections with point clouds as your background. As can be seen in this historical church example, we have added a modern CAD elevator with point cloud as a background, and the BIM section can be annotated with tags and spot elevations. With BricsCAD's unmatched point cloud, Scan to BIM has a new life. We look forward to support you in your projects and better deliver design and construction workflows with BricsCAD. We will now move on to our next session on BricsCAD BIM. I will now invite my colleague Claire to take over the stage. Thank you.
Hello and welcome again. For this next session, we'll be talking about BricsCAD BIM. We'll be talking about the latest developments to BricsCAD BIM workflow. BricsCAD BIM works with this thought in mind, a building design workflow that keeps design first. What does this mean? As a team of architects and engineers ourselves, we are aware that the typical BIM design process is a broken workflow that involves multiple tools that do not exchange data in a consistent way. As a result, you spend a lot of time in manual, redundant, and repetitive work to create and recreate the deliverables needed in each phase of the building design lifecycle. It is our goal to deliver an automated end-to-end workflow for architectural design, construction documentation, and building product manufacturing. By leveraging automation, we let you focus on what you do best, which is the design of your building. We will walk you through this end-to-end workflow in this presentation. In the first part, we will explain how you can start sculpting your conceptual design in BricsCAD BIM. Conceptual design is where we convert our ideas into a massing model to help us understand the project from a 3D massing view. Unlike traditional BIM tools, you can use an intuitive push-pull direct modeling combined with a parametric modeling, which is not limited by predefined parts or libraries of components. As a result, you experience design freedom with a full 3D workflow that will feed immediately in the BIM later on in the process. We can use direct modeling, import a geometry, or use grasshopper connection to create a massing model. Now what we are seeing here is a direct modeling approach to sculpt a 3D volume and create the shape of the building that we have in mind. Next, we are using a custom script to slice according to X, Y, and Z directions, and then remove the partially sliced cells to achieve the shape that we want. As we see here, we are just using this structure panel to edit out a few of the other components, and we can have different alternatives to this form study. We'll see a few more of those studies here. With the building massing we created, we can now show a first example of automation. We're going to use Quick Building to transform our model to an LOD 200 model automatically. Quick Building will shell the mass volume, and it will automatically create walls, slabs, and spatial elements, like spaces, buildings, and stories. We created a section plane, and we can see that the walls and slabs have been created. We can use the structure tree to isolate slabs to see how the model was created. Now, as part of V21, we have introduced a new quantity framework that allows you to configure user-defined quantities. Let's see that. In this case, let's create a user-defined quantity for the compactness of the building. This can be calculated by using the formula gross volume divided by the total surface gross area of our building shape. Let's input that now. And once done, we will be able to see the new information in the Properties panel on the right side. And let's see that. We'll go down and see that here, the compactness is now shown. What we have seen is a transformation of a mass model to a concept model with floors, slabs, and spatial elements. This can be used now for evaluating design options not only geometrically, but also with quantities like compactness or floor-to-site ratio. Last year at the Bricsys conference, we announced a multi-year initiative to advance scan-to-BIM technology involving point cloud, in cooperation with our partners HOK and Leica Geosystems. We will see more of that in a separate session. Now, we will discuss more on other automation developments in BricsCAD BIM, which our partners from HOK helped to guide. This cooperation with a very respected name in the industry creates a solution that is based on customer requirements. In the next part of our presentation, we will develop our concept model into a full information-rich BIM information model. BricsCAD BIM leverages the power of artificial intelligence through machine learning algorithms to automatically convert your concept study models to a fully classified BIM model. Now, before we go into the automation part, we would like to introduce the demo model that we will be using in the remainder of this presentation. The Kentucky International Convention Center, a 90,000 square meter building with exhibit space, a conference theater, over 50 meeting rooms, and a full-service kitchen. This model was developed in collaboration with our industry partner HOK to test the performance and scalability of new developments in BricsCAD V21 in a real-life project. Let's now hear from Greg Schleusner, a design technology director at HOK, about how we work together with industry partners like HOK to advance our future roadmap.
When we started working with Bricsys, we chose an existing project to reverse engineer, i.e., take a project we've already built, designed in other platforms, and rebuild that and use that basis of our work. So last year you saw the model reconstructed. This year you're going to see it used in demos. One of the main areas we focused on was drawing automation. And specifically, we started with something like fire life safety, which is a lot of effort. So you can see here, these kind of drawings are really laborious to produce. And so that was the basis of the collaboration. We think this way of working is a perfect process to go back and forth, to use the work that we've already done and help engage and add to the development of Bricsys.
The first and foremost challenge with working with this kind of large-scale project is, of course, performance. Our strategy to handle big models is very simple and straightforward. Split it up in smaller parts. All these separate models are combined into one master model, which is still slow to open when it contains a large number of models. To address this, in BricsCAD V21, we introduced background loading of XREFs. We can open the large master in just a second while all the nested submodels are being loaded. Independent of the size and complexity of the XREFs, the master model opens instantly. The overall structure is displayed in low detail, while detail XREFs load. This allows you to already inspect data up front, like building and story information. Now that the entire model is ready, we will focus on a smaller part. Here would be the main mezzanine of the southwest part of this entire model, to show how we go from geometry to BIM using our AI tools. Let's now open the mezzanine model as a separate DWG file. Now let's see here from the structure tree. Let's just go to the structure tree and see the entities, and we will see that we have about 410 solids. Now we want to convert these solids into information-rich BIM entities like walls and slabs. And normally this would be a lot of manual work, but this is where automation comes in. In BricsCAD, BIMify does auto-classification based on machine learning algorithms that were trained on a large database of BIM models. And now it's able to detect BIM types based on geometric attributes of the solids. It now starts scanning the entire model to classify, detect buildings and stories, and spaces. The goal here is that BIMify does the majority of the work, but as a designer, you can still overrule or change the classifications manually. So for example, here in the structure tree, let's just go here and see the building elements. And let's see the building elements. Actually, these are furnishing elements. So we can see these, and now we can actually select these and reclassify them as furnishing elements. And now we can go back to the structure tree and isolate some walls to see how the model is structured. And we can see that BIMify actually successfully classified these walls. And that's great. Now we will see how we can create and work with the new spaces in BricsCAD V21. Other than classifying objects, BIMify also automatically created spaces in the model. It found enclosing architectural elements in the model such as walls, slabs, and columns. And it created spaces, and these are now space objects. Let's see those. And we see in the structure browser, we can isolate these. And let's see what that gives us. We'll see that these are actually solid objects. And we can also represent them by footprint, like what we're going to be doing now. Let's see that. We can do that from the properties panel. And we'll get a very clear overview of the spaces in our model. Of course, these spaces are still linked to their enclosing entities. So meaning, let's see here, for example, let's move one wall. So let's say we move a wall. We'll see that the enclosed space will be flagged. And let's see that. We see here that exclamation point is telling us that now it's out of date, and we can update those accordingly. And let's do that here. And we see that. Now, in order to further increase the level of development of this model, we can also start adding compositions to the walls and slabs. For example, for this model, we can see that there are coverings on the structural columns, which can serve as fire casings. So from the structure tree, we can easily select all the coverings and apply compositions by drag and drop from the composition panel. Now, after this is done, we can increase the LOD even more by applying details from our detail library. In this case, we want to apply a skirting board detail to the column coverings, which will help to improve air tightness and serve as additional protection from heavy objects. We can drag and drop or propagate the detail throughout the model. This means that it will scan and find all possible applications of the detail in the entire model by trying to find the exact same situations in the model where this detail can be applied. This saves a lot of time and also allows you to increase the level of development in the model consistently, not only in a single place. In this case, we see that we have 128 applications that Propagate has found. We can manually select the indicators to choose whether to keep or ignore these details. So as a designer, you still have full control. If you accept the changes, the geometric applications are directly applied to the solids in all the detected places. As a next step of automation, it is possible to use scripting Python, which is a high-level intuitive syntax for usage in BIM without needing a lot of development knowledge. So for example, we are interested to see some key numbers about this model. Occupancy of the rooms or the areas of different types of rooms. So using Python, we can easily visualize the data using one of the many Python libraries that are available. So the results of the area and occupancy analysis can be shown in real time from the BIM session. And this gives us insight on how the model works. So up to this point, we have actually seen a lot of AI to automate tedious parts in the BIM workflow. And why is this? What is exactly the vision of the Bricsys R&D and AI team? It actually goes back to the process. About 80% of the time spent in a BIM project goes to labor-intensive repetitive work, while only 20% goes to the actual design work. Think about all the BIM data that needs to be added to the model, creating and recreating details over and over, as well as generating and annotating drawings. This is why the Bricsys R&D and AI team focuses on intelligent design, and they focus on assistant tools that automate these repetitive tasks and give time to the designers, architects, engineers to focus on what really matters, the design and problem solving. Now, we've seen quite a few of these tools earlier, but there are other opportunities for improvements. We see that the drawing generation, for instance, is typically taking a lot of time and manual work. So another one would be checking of design requirements in your model. This brings us to the next step in the workflow, which is construction documentation. Creating the documentation for a building project is often the most laborious and error-prone part of the architect's building design workflow. Our goal here is to create clear and accurate construction documentation and give the user complete control on how the 2D drawings will look like, including automation of tab placement and drawing customizations. Then, these automatically created sheets can be freely annotated and dimensioned using the 2D drafting tools that are available natively in DWG, while the drawing views stay in sync with the 3D model. Our master model was created by combining several XREFs. Section planes and elevations were created for each of these, and as a result, the entire model now has more than 700 section volumes. Now we have isolated one that we can discuss further. The project browser can be used to create and manage your construction documents using your company standards. It gives a full overview of all of your sections, sheets, and models that are part of your project. We can open a sheet to see how it looks, including title blocks and views. You can automatically add composition tags as well. The information shown for these tags is of course customizable. So let's add a couple of these composition tags to illustrate these. You can also add spot elevations to show the finished floor levels, or FFLs. And we will be seeing that. And let's add a couple of those as well, just to see this illustrated clearly in the demo today. Moreover, you can also do dimensioning easily. We'll see that here, and other annotations, you can also do those, while your 3D model is still kept in sync. So that's very useful. Now, how about other automation tools to make the process even smoother? Let's now talk about how we can take advantage of more automation in BricsCAD BIM. We see here two drawings. On the left, fire strategy. On the right, space strategy. They're actually pertaining to the same floor plan, just showing different information. This is typical in larger projects. We have several 2D drawings derived from 3D models, for example. Construction drawings, structural view, fire and safety documentation, and others. So in order to avoid a lot of the manual work when creating these drawings, the Bricsys team developed drawing customizations. Drawing customizations are templates that you can create once and reuse in all your projects. You can create rules on how certain elements with certain properties are shown on a specific customization. So for example, you may want to show 1 hour fire rated walls as red and other walls with a different fire rating to be shown in a different color as well. Hence, a lot of touch-ups in your documentation drawings are no longer needed, and a lot of potential errors in the process are avoided as well. Let's see that in action. We start from a sheet with two viewports of the same section result. The end goal is to create two types of customized plans, fire safety plan and space area plan as we saw earlier. Drawing customizations are closely linked to properties in the BIM model, so we go first to the 3D model. Let's go back there. So we have added information about fire safety properties in the BIM, half an hour, 1 hour, and 2 hour fire ratings. So we see that in the properties panel. And we will be selecting walls in the structure tree, and we will see that the walls will also have the corresponding fire ratings. Depending on the fire safety property, we want to give the walls a different representation on our floor plans. So step 1 would be to define the actual style definition. So we want to define how different types of lines will look like. For example, for walls with 1 hour fire rating, we want the intersection fill to be shown in red. And of course, we can also control all other line types here. Secondly, we don't want to just overwrite how the walls look like, but we also want to change how components show up on plans, particularly doors, automatically operated doors. So let's do that using a special tab. We can choose specific symbols to show up. So we can use an external DWG file for that symbol. And step 3 would be to define the rules to map properties to this specific tile definition. So we will be using the rules of the walls and the doors that map the properties and the customization. We'll see that, and we'll be applying the customization to the viewport, and we will be seeing that the colors of the walls and the tags for the automatically operated doors are reflected on the plan. Now, earlier we also saw that there is a second example, the space area plan. We use the same floor plan and we add a second customization file, which we actually already prepared. This one adds color to the spaces according to the function. So for example, a kitchen, a storage, a toilet. And we will see that the floor plan is easier to read. So one of the advantages is that definition of customizations are external to content. You can use this different kinds of geometry like supported Rhino geometry, IFC, and others. We can also create customization based on company-wide standards and reuse them in different projects. Now let's move on to the next part of the process, and I will let Sagar, our technical lead in APAC, take over from this point.
Thank you, Claire. Welcome, everybody. In this part of the session, we will discuss the new enhancements to the visualization and collaboration functionalities of BricsCAD BIM.
As an architect or designer, you probably want to showcase your first design steps to your client. Last year, we announced a partnership with Enscape for real-time, high-quality rendering as part of the Bricsys Collective. This year, we are proud to offer a new member of the Bricsys Collective, Twinmotion from Unreal. Belinda Erkin, Product Marketing Manager at Twinmotion, will talk about the value this new integration can add to our customers.
This partnership is going to bring the whole range of Twinmotion's real-time capabilities to all BricsCAD users. Twinmotion is part of Epic Games, the developer of the Unreal Engine. And Epic Games brings a wealth of knowledge and history within the real-time technology space, where we have been pioneering and continuously driving real-time technology advancements through the engine. So we are very excited to help leverage the power of BricsCAD's unique and smart feature set, with Twinmotion enhancing the architectural design pipeline. And one of the essential core features of Twinmotion is that you can skip the time-consuming import and export process, because with Twinmotion you can really rapidly bring CAD data or your BIM data over to Twinmotion through the one-click direct link synchronization, which will be a plugin inside BricsCAD, and it will enable you to easily import your files into Twinmotion directly. And then once you're inside Twinmotion, it's easy to learn and use, because Twinmotion was designed this way. It was designed to be simple and easy to use by combining this intuitive icon-driven interface, drag and drop assets. You have these beautiful one-click workflows, so you'll be able to get started quite quickly and be productive right out of the box. So overall, it's a very intuitive experience. And BricsCAD users can be excited about all these new ways of visualizing your data with Twinmotion, having the Unreal Engine as the underlying technology. You can create beautiful visualizations and animations with a really smooth user experience. So thank you very much, and we are looking forward to seeing you create such compelling stories.
We will now look at this model created in BricsCAD BIM, and we will export the master model as a single file. All XREFs will be included using datasmith file format TS, which is used to exchange data with Twinmotion and Unreal. We see that we can create renders and animations in Twinmotion, starting from an imported datasmith file. When importing the datasmith file into Twinmotion, you will notice the same structure as in BricsCAD BIM. So you can find the same XREF names, layer structures, and same classification types. This makes it very easy to navigate through your model. Twinmotion comes with a big library of textures and assets which are very easy to apply. For instance, we can drag a concrete material onto these columns, and you see that the texture changes at the same time. Same can be done for glass. We can simply drag and drop this texture, and it instantly makes the model look more realistic. We can also add other assets such as trees and other vegetation. Let's now see some renders and animations made using Twinmotion. In the final part of this session, we will focus on collaboration. BIM is not just about working in isolation. It's about creating, sharing, and collaborating with project partners across the globe. So we need to ensure that everyone can work together regardless of their design platform. In BricsCAD BIM, we enable this collaboration through the use of open standards like IFC and BCF, which is the preferred way of BIM information. As a complementary workflow, we also offer different interoperability possibilities with other BIM authoring tools like Rhino Grasshopper for generative design, and now with V21, also with Revit through RFA and RVT imports. We at Bricsys believe in the open BIM approach. That's why Bricsys is an international member of Building Smart, the organization that creates the open standards needed to make that possible. The first one is IFC, the open software independent file format used to share data-rich BIM models. With IFC, you can combine different models, architectural, structural, MEP, and so on. coming from different modeling tools into one federated building information model, where you can do quality checks, clash detections, and much more. BricsCAD BIM also let you import IFC files. What's amazing is that all the building elements are loaded as native objects, and you can edit them just like any other object. That's what OpenBIM is truly about. No more closed systems, no more closed file formats. BricsCAD BIM is even IFC certified, which guarantees the quality and reliability of the workflow. But that's not all. In a typical BIM project, you also want to communicate effectively on issues, change requests, and so on. From now on, we can do that with BCF, the BIM collaboration format. No more back and forth emailing, trying to describe what the issue is. BCF immediately lets you zoom in on the exact location where the issue is, show you who needs to resolve it and how urgent it is. We already supported multiple BCF platforms, and now we can add BIM track to that list. By fully supporting the OpenBIM approach and continuously improving both IFC and BCF support, BricsCAD makes collaboration easier than ever. For this demo, we will start from one part of the roof structure of the KICC that spans the entire exhibit hall. We are going to show an BCF IFC workflow to resolve an issue in the model. Using the Issues panel, we can connect to several BCF services, including BIM Collab or BIM Track, where we can see a list of all open issues that needs to be addressed. We see there is one issue about a missing connection detail between beams, so we can check the issue to go to the correct location in the model. To resolve it, let's propagate a detail from the Details panel. We have prepared a detail with a connection for steel beams with a plate and fasteners. Upon dragging and dropping, Propagate will scan the model and find all possible applications where this can be applied. After this is done, we will accept all 48 connections. If we zoom in, we can see that the detail has been added and the issue seems to be resolved. So we can add a comment in our Issues panel. We can say that the issue has been fixed and ask to check the integrity of the bolted connection. We can add a screenshot and add the comment to the issue. A second part of an OpenBIM workflow is working with IFC. We have worked on performance and stability of IFC, but we also added several improvements like internal BIM types with IFC types, which gives them more control over how entities are exported and imported to IFC. We see that we have now exported this model of the roof structure to IFC. Once that's done, we can open the IFC model in an IFC viewer, for example, in our Bricsys 24/7 common data environment, to see what it looks like. So Bricsys 24/7 is a fully functional cloud-based collaboration design platform where you can store all your files, all your design files, all your documents. You can review these files and you can upload and download anytime and have direct access from the BricsCAD 24/7 panel inside the software. In V21, we have also added improved interoperability possibilities with other file formats, including Revit models and families. In order to do this, we work together with Open Design Alliance, who has built a BIM SDK to support interoperability with different file formats. Open Design Alliance is a non-profit technology consortium that develops interoperability solutions for CAD and BIM industries. They partner with Building Smart International to support open standards such as IFC, and they also provide toolkits for proprietary design formats such as Revit. To show the Revit functionality, let's start with an empty drawing and import a Revit file of a typical office building. We can import the file as an underlay, or we can directly import the Revit data as native solids. We can also choose to filter the Revit data by view, categories, levels, worksets. In this example, we will import by categories. For example, we want to import the floor plan layout without furniture, spaces, and current flow terminals like light fixtures. We can do this by excluding them from the dialog. After this, we can then see how the import looks like in BricsCAD. In this version, only the geometry is imported, but we can use tools like Bimify to turn the geometric models into building information models. Once the model has been BIMified, we can check the structure tree and we can see that different BIM types have been detected. We can isolate the walls and slabs. We can see that they have been detected correctly. So this new Revit functionality enables a workflow where you work together with stakeholders or teams that work with Revit data. For example, we can start doing an interior layout by adding office desks and try different layouts directly on this imported Revit data. But of course, other workflows are also possible. We see that this new Revit import functionality is a complementary workflow to working with open standards like IFC, enhancing design collaboration capabilities for different teams across the globe. Another question that we hear often is how BricsCAD BIM allows multiple users to work together on the same model at the same time. The requirements for such a collaboration systems are not straightforward. Architects want the possibility to work offline on multi-user projects, so not having to be connected with the cloud server all the time. Also, architects don't want to work with huge files, which they have to send across for each and every small change that they want to make. Why need to download entire file if you only need a small adjustment? In V21, we have worked on a multi-user workflow that is based on Git versioning control and is built on top of DWG. Version control is a system that records changes to files over time so that you can recall specific versions later. It is a proven solution for collaboration, well known in other industries like software development. It also allows architects to collaborate with other users across the globe, as every architect can check out files locally from a central server. The advantages are that everyone knows what everyone else is doing, and administrators have control over who can do what. Also, it allows you to work with smaller models, so there is no need to download the entire model if you only need to make a small adjustment on a specific part. It also allows you to work offline as well as online on multi-user projects, so it does not require you to be online all the time. Now available as a beta functionality in V21. In this presentation, we have shown several ways to automate parts of your BIM workflow. In the future, we want to continue to follow this direction and take away the error-prone and time-consuming parts. On the modeling part, we want to make it easier to increase the level of detail of your BIM using tools like Propagate and Copy Guided, but also make it easy and intuitive to do conceptual design. On the BIM part, we want to automate going from a concept model to an information-rich BIM using tools like Bimify and the ability to create quantity takeoffs from your BIM. On the construction drawing part, we continue improving automation of dimensioning and annotations on the 2D drawings. We hope you enjoyed this presentation, and we look forward to your feedback on BricsCAD BIM V21.
And now, for the next session, I would like to welcome our colleague from Leica Geosystems, Mr. Neil Ashcroft. In this presentation, you will witness the revolutionary collaboration for scan to BIM and BIM to field workflows, powered by Leica's high-definition surveying technology and BricsCAD's powerful 3D modeling and cloud collaboration.
Great, thanks for the introduction. My name is Neil Ashcroft. I'm the Regional Technical Manager for Leica Geosystems here in Asia. And this session I'll be talking about the field to BIM and the BIM to field workflows. So without further ado, let's get going. So at Hexagon, we believe in fusing the real and digital worlds to create dynamic and actionable data. With the combination of our sensors and the software solutions we provide, it is our intention to transform the geospatial industry we serve. So we need to digitize this reality and leverage on the content that we capture. Tools of the past. This is really about educating the decision makers. What will happen to companies that don't meet their customers' digital demands? Will they grow or even exist in the next 10 years? The measurement tools of the future are digital. At Leica Geosystems, we only have one product range left that's entirely manually operated, the optical levels. So on the left, we see the manual, the analog technique of measuring distances, and the right, the new norm, using digital tools to measure distances electronically and subsequently store the observations inside the sensor, and then we can transfer to the computer and upload into various digital design packages. Through the life cycle of a construction project, Hexagon solutions are fully present. Digitizing the actual reality by using various measurement sensors such as GNSS, UAVs, total stations, ground penetrating radar, and of course laser scanners, which we'll go into more detail shortly. Digitized data is then passed over to design and modeling tools such as BricsCAD to generate BIM models that will subsequently be used in the field to lay out design positions in a seamless manner. To ensure that the facility has been built in the correct place, follow-up verifications are carried out using the same sensors in the initial measurement and setting out processes, such as laser scanners and total stations. It is then a relatively straightforward process to modify the design BIM model to an as-is or final as-built model, which are then passed on to operational and maintenance of the facility. Reality is now captured with laser scanners. Such a scanner seen here rotates around its axis, emitting a laser, which then measures angles and distances to remote surfaces. Inside or outside, the actual reality is measured and made digital. Here we see the resultant measurements, many individual points, or a point cloud. The first representation here shows the intensity of the returning laser, and the second representation overlays true color to allow better interpretation of the objects being scanned. Our recent addition to the family of Leica laser scanners is the BLK2Go, a handheld mobile laser scanner that measures interiors to positional accuracy of 2 to 3 centimeters. So yes, indeed, a nice point cloud. Now what do I do with it? These point clouds can contain millions, if not billions of points. Using a Leica CloudWorks plugin, this enables tools such as BricsCAD, Cyclone 3DR to create models, compare against existing models, determine clashes, and even enable data sharing. Actionable real-world data. So by taking these point clouds into the likes of BricsCAD, we can then do dimensions and take measurements as if we're in the real world. A point cloud delivers a complete 3D picture. See the spaces between spaces, and virtually visit your assets, especially relevant during this time of COVID-19. This allows us to base our design on reality. Be assured that the design decisions that are made are accurate and achievable. However, modeling from scan data is quite time consuming, so really only model what you have. The point cloud is the truth, so use that alone where possible. The data can be used to validate these existing plans and models to ensure what we are given is accurate. Other tools like the CloudWorks plugin for BricsCAD do allow some semi-automatic creation of geometry from the point cloud. The best fit geometry to the point cloud to speed up the process and improve the accuracy of created models. It's not completely automatic. There is some need to do some manual processing, but you can quickly create 3D models using the point cloud as a reference. The deviation checks allows us to identify any pre-construction, particularly in renovation projects, where we can understand if an area of the site may need additional work to make it ready for construction, such as grinding down an existing concrete slab. Capture and validate the positional accuracy of any component. We are able to check the facade of a building for any potential movement or deviations from a design intent. And then by creating a heat map, we're able to share this information in an easy to understand way, allowing us to make quicker decisions.
So I'd like to introduce you to the intelligent construction products within Leica Geosystems. This is the Leica Icon product portfolio. So the Icon products we're talking about are the GNSS sensors, those are the ones in the poles, and total stations, which you see on the tripods. These are fundamentally setting out coordinates from your design model along long linear structures such as roads, railways, tunnels, or vertical structures such as buildings. Okay, let's put what we have seen into a short video. So this is a full end-to-end workflow of capturing reality using a laser scanner. The resultant point cloud is referenced into BricsCAD using Leica CloudWorks, whereupon a 3D model is created. Additional design components are then added for subsequent setting out back in the field, transferring using Bricsys 24/7. So let's go. Great, so I hope you spotted the Bricsys 24/7. It was exporting some DWG files, the final DWG files, out to the field. So this ensures that the latest version is always available for the surveyors out on site. So after transferring the IFC file or DWG or even the DXF file onto the icon sensor, we can start to set out boundaries. We can start to set out the building footprints for the construction of the towers or the structure. We can also run QC checks to make sure that the buildings are put in the right place. So this is what the icon total station looks like. And this is the tool that we use to go from the BIM design off to the field. So in summary, a recap of the life cycle of a building or a construction site, from the initial surveying using various tools for capturing the reality, the planning into design software like your Bricsys suite of products, setting it out, taking it across to the icon products, doing some setting out for utility underground services, and then the actual construction where we need to make sure that the building is progressing as designed, and then some of the validation before we hand it across to the end user for the facilities management and the operations of the building. So there we go. Any questions at all? Or maybe perhaps we'll wait till the questions at the end. Well, thanks very much. I hope to speak to you soon. Bye-bye.
Thank you very much, Neil. For the next part of the session, I would like to introduce my colleague Jonathan Taylor from Civil Site Design. He will take us through civil engineering design built into BricsCAD.
Welcome everybody to this presentation of BricsCAD with Civil Site Design. My name is Jonathan Taylor and I'm the Technical Marketing Manager for Civil Survey Solutions, and today I'm going to be demonstrating to you how our civil infrastructure design solution integrates with the BricsCAD environment. Just before I do that, we're going to give you a little bit of information about Civil Survey Solutions. We've been focused on developing software for the infrastructure marketplace for over 20 years now. We've got a team made up of predominantly civil engineers and surveyors, meaning we've got a wealth of industry experience behind all the development that goes into our software and our products. Initially established in Australia, we've now expanded into the US, specifically Florida. We are an official Bricsys solutions partner, and this means we operate very closely with Bricsys in developing compatible solutions for their products, in this case BricsCAD. The main solutions we develop are Civil Site Design, which we're going to be seeing today, and Stringer Survey Suite. And just as an aside, Stringer Survey Suite is a range of surveying tools which allows surveyors to bring field data from their machines into the drawing environment. So today I'm going to be showing you Civil Site Design. And for those of you that aren't aware, Civil Site Design is recognised as the civil infrastructure design solution for BricsCAD, as you can see on the BricsCAD website. And it's also one of the most popular downloads from the Bricsys application store. So what is Civil Site Design? Well, in summary, Civil Site Design is a civil design package for the design and documentation of a range of disciplines from earthworks to roads and to pipes. All of those you'll be seeing in some context today, whilst being created in a fast and familiar CAD environment, and in this case, BricsCAD. So here's a quick summary of what you're going to be seeing today. So we're going to be creating tin surfaces. We're going to be seeing those in 3D. The visualization part of this demonstration is going to be all the way through. We're going to be undertaking some earthworks, creating some roads, creating combined surfaces from the natural and the design, and then looking at some pipe design to conclude. So let's have a look at the software. So I'm running BricsCAD with the BIM workspace enabled, and the reason for this is so we can harness and collaboratively work with some of the tools found in the Civil tab within BricsCAD. This will enable us to import and export and share basically surfaces between Civil Site Design and BricsCAD. We're going to focus on the Surfaces tab, so we have a range of tabs being provided at the top here with a selection of different tools. Now the first thing we'd maybe look to do is create a surface within this particular project. The tools that Civil Site Design provides allows us to create surfaces from, say, CAD objects, 3D faces, points, 3D polylines, XML files, and also text files. What we're going to do is use the Create Edit Surface button here to create a brand new surface in the project using CAD information that was provided by the surveyor. This surfaces form allows us to go ahead and create and manage our surfaces in the one form. So as you can see here, we can import and export XML, and for the keen-eyed viewers, you will have noticed in the Civil tab a second ago, you also have the option even of importing an XML and exporting an XML as well. We have the option to basically go and search for layers within the drawing that contain this particular object type, and there happens to be an object type called 3D faces found on a layer called surfaces 3D faces. So immediately we can go and select that layer, click on add, and then down the bottom click on build. And the way in which Civil Site Design works is that it's very much plug and play. So this form is what's known as modeless, means that we can have it parked off to a different screen, see what the reaction is within the drawing environment to any changes that we make. You can see here we've got other options to import layers of points, layers of 3D polylines or break lines, point files, and even the inclusion of adding a boundary. Now, whilst we're here, we may as well quickly have a look at how you can change the display of this surface. And again, it's all plug and play, so as we make changes within the Outputs tab and click on Update Display, we'll visually be able to see in the drawing environment what's happening. So we can do things like turn on the triangulation. We may as well just turn that off for the time being, but changing things like the contour interval, just regular design changes that you may wish to make. As we make changes, I didn't even have to click Update Display there. Contour labeling we can add, slope arrows, so we may want to see how the surface begins to change in regards to falls across the site, basically the steepness of those particular areas within the site. And again, we can turn these things on and off, and if we were to go ahead and make changes to those objects that are within that particular layer, this surface will update, and all this information that we're being provided will also update. Now, once we've done this, we can close the form down and immediately visualize this in 3D. Whilst we can see contours and triangles, to actually see how this surface looks in 3D is incredibly important. We can do that through Model Viewer. Once Model Viewer is open, we can select a surface, and from there we can click OK. And what will happen is it will open up a separate form, as you can see here, and we're able to go ahead and use our mouse to navigate, just using our mouse wheel here, scrolling and holding it down to navigate around the surface. To give us some more context, what we might decide to do is to see the aerial image that we have placed in the drawing environment on this particular surface. So we're going to go up to Toggle Display and ask it to show the aerial image. And very simply, we pick it from the drawing. So it's nice and intuitive. We don't have to go off searching for files. We can pick it from the drawing if it's in the right position, and the software will simply place the image over the top of the surface. Last little bit of context for this, we may decide that we want to see some contours as well. Because we've created a surface, we can see these by clicking on OK. Any changes we make to this later on, we can see the update, which is fantastic. So just very quickly there, within literally the space of a minute or so, I'm able to now visualize this surface in 3D. Any changes that we make will automatically be updated. We'll come back to Model Viewer in a second. What we'll do very quickly is now look at how we can apply what's known as grading strings. So these are objects within the drawing that are for sort of free-form shapes. So we might have a basin down here, or we may have a building platform, and we want to begin to create some design elements and maybe have a look at volumes. So let's do that now. We're going to go up to the Grading tab, click on Create Grading, and select our polyline. And in here we can just begin to populate some information. So we can say what this is. This is a basin. We can use a template. So Civil Site Design offers a range of template shapes. So these could be for a road, these could be for a basin. Let's just very quickly look at how these things are set up. Clicking on the pencil icon takes us to our template library. So this is where all of the templates are stored for this particular project. So as you can see here, we've got a very typical road shape that we can use. In this case, we're going to be using one called a basin. So this is a very typical kind of basin shape, working out from the polyline all the way up to the natural surface. You can see by clicking on the blue button up here, we can select through a range of different templates. And the idea is that the user goes ahead and they create their own library themselves, possibly using some of the content that we've got provided. So we're just going to click Cancel. We're going to go ahead and pick our template. tell it what surface we'd like to reference in the background, give it an initial elevation. So how high do we want this basin to be? Well, it's 29. We've already written that value, so type in 29. And all we need to do at this point is very simply click Create Update. And that template will have been applied. The batters that were going around the edge, or the daylight that was going around the edge, will have now interpolated where that natural surface struck that particular template, and we've now got a shape. Let's now quickly have a look at Model Viewer. So Model Viewer, you can just park this format away, will allow us to now show that basin. So we're going to go up here and ask it to show the basin. As you can see, it's been created. Click OK, and there is the basin. I can now go ahead and make changes to that particular elevation. Let's say it shouldn't be 29 anymore, it should be 31. Click on Create Update. In the drawing, it updates, as you can see there, but you will have seen also immediately we've got this instantaneous change happening in Model Viewer as well. So we get immediate contextual feedback as to what's happening with our design. I can also obtain a volume. So if I wanted a volume of this particular basin object against the surface, we can click on Compute Volumes, and I'm able to obtain immediate updated volume quantities and areas. Now, in respect of the road design, we have some tools which will enable the designer to begin to create roads within the project extremely quickly. Now, this is done using, first of all, the Alignments tab. So what would generally happen is the user would go ahead and select polylines, which would form the crown or the center line of your typical road. Doesn't always have to be that way, but they can basically be the control point for your particular road shape. They can also be used to help design things like parking bays, car parks, introduce widening, all sorts of different things. So to save time within this particular presentation, we've actually gone ahead and created those alignments initially. So we can now be going to go ahead and create some roads. So we're going to go up to the Roads tab. And first of all, I'll just make mention of this. We did look at this earlier. Typically, we would look at creating some kind of road shape. As you saw there earlier in the template editor, we've already got some road shapes available. So what we might do is go ahead and look at creating a multitude of roads using some of the automated software within Civil Site Design. We're going to go up to the Road String pull down and click on Auto Create Roads. What the software will allow us to do is to select a typical template. So this template will be applied to all of our roads. Select a surface that will be referenced for any batters, basically any surface in the background. And all we need to do is click OK. And then choose all of the roads which are going to have this template applied, or all of the alignments that are going to have this road applied. So we're going to choose Road 1, Road 2, and Road 3, which are the main roads within the project. And we're going to go with the existing road crown, which is our existing road down the middle, and we're going to click on OK. So the software goes ahead, it applies that particular road shape. Now let's see what's happening in the background with regards to the vertical design of this particular these particular roads. We can click on the Edit Design button and click near to our string, which has been created. And we have what's known as the vertical grading editor. So the vertical grading editor is a form which allows you to manipulate and design the vertical geometry of your particular string. And this applies to any string. This could have been our grading string where we created the basin. Now, very cleverly, the software will go ahead and place a sort of line of best fit over the existing surface, which we can choose to remove. We're just going to get rid of that. You can see as I do that in the background, the software is reacting to those particular changes. Let's just go and add some more very quickly into the design. So we're going to be putting in basically a vertical design based on IPs. So we're going to put some vertical curves in here. Very simple, just a few of them, just to get a little bit of design going on. Now the designer has a whole bank of tools up here to help work with that design, edit that design. We include some analysis. You're also able to apply constraints or projections from other parts of your design to help you visualize and understand how it relates to other areas of your project. Now, if I just move this off to one side and right click, I can generate a cross section. And if I just zoom in with my mouse wheel here and scroll my mouse wheel at the top of the form, you can see here I can very quickly begin to scroll through all of my cross sections with all of these forms open at the same time. If I go ahead and make a design change, for example, I may want to make a design change to this IP here, I can very quickly make that change, but the important thing to note is that as I make that change, I'm getting that contextual feedback in the cross-section window, and once I've clicked, in the drawing as well. Now, we've created some roads. We now need to create some curb returns to connect these up. The software has intelligently connected the roads together because of the string type we've used. We're just going to close down these two forms and ask the software to go ahead and create curb returns, or connections basically, between all of these roads where there is no existing curb returns. So we're going to go up to network strings, auto curb returns. We'll leave the default radius at 10 meters and click OK. And you'll see there that software has now connected up the curb returns with 10-meter radius. Now let's quickly go and have a look at what's happening in Model Viewer. So we're going to basically enable Model Viewer to show us the road design, and we're going to go up to Toggle Display and go to the Primary Design button, click on Total Model, which is the model of the road design, and we'll also get it to show the contours by clicking on Total Model here. So we can now see our road design, and you can see there. Let's do what we did earlier. Let's make a change to the road design. Now, because we're in Model Viewer, we can actually start to harness some of the tools that are found on the ribbon simply within a right click. If I right click near my road, open the vertical grading editor, and let's make a change to the design here by putting this right back up. And due to the dynamic nature of the software, we can now see the changes being applied in Model Viewer and the drawing environment whilst we're designing. Let's close down Model Viewer. Now we're going to share this surface with BricsCAD, and to do this we're going to go up to the BricsCAD Surfaces button, and we're going to add what's known as a surface exchange. So this is a live exchange of one surface from Civil Site Design to BricsCAD, which will continue to be live as we'll demonstrate in a second. So we're going to click on Add Surface Exchange, Civil Site Design to BricsCAD, and we're actually going to pick strings from model. So this is our live road design. We're going to tell this that this is our design. We're going to pick the design model, which is in this case Total Model, and click on Add Item. Then click on Build Update. Now, you may see in the background here we now have an alternative set of contours. Now these actually belong to the BricsCAD surface. So what we'll do here is, because we've applied sync, this means that any changes we make to the road design will update to the BricsCAD surface. So let's just have a quick look at this. Let's click on Close. If we left click on one of these contours, then right click and go Properties, just move this over to one side, you'll see that we have a BricsCAD tin surface with the contour ranges and intervals and colors, etc., all set up. Now the great thing is, if I make changes to this design, so we might do that now. So we're going to go to the Road tab, Edit Design, and we'll click on this particular road, Road 1, and we'll do something fairly drastic. We're going to raise the entire road up by 1 meter and then click OK. Now the purpose of doing this is to really demonstrate to you how everything is integrated and interactive. So if I can now close this down, you'll see the contours have also updated. So this is for our road design, our pasted surface, and the BricsCAD surface. Let's now close that down. What we may now look at doing is combining these surfaces together. So to do this, we're going to go up to the Surfaces tab, click on Pasted Surfaces, click on Add Group. So we're going to create a combined surface which will include our basin, our natural surface, and the road design. Click on Build, and then we're going to click on Close. And you'll have seen in the background that the surface will have been created. So what we'll do is just give it a little bit of clarity here, turn off the contours of our surface here. You can actually see the contours remaining here for our BricsCAD surface. That will continue to update in the background. Now the great thing is we can now use this for drainage. So I'm going to go ahead and turn on a set of layers to enable us to put a very quick drainage design onto this particular project. So you can see we've got these yellow polylines representing the pipes and the positions of where the pits or manholes will be placed at each intersection. Just before we do this, we might actually just turn off the display of the pasted surface as well and click OK. And because the BricsCAD surface is sitting there in the background, we could just turn the layer off. All I'm simply going to do is simply just delete it. We can always go back and recreate using this BricsCAD surfaces button later. So let's very quickly create some drainage. This involves the Pipes tab. And what we're going to do is to ask it to create some surface water drainage. We're going to click on Drainage Objects, and then within the form we're going to pre-populate some of this information here. So the pit or the structure that is going to be used generically through this project, some pipes as well. So we've got a whole library of pits and pipes already part of the software. We're then going to choose a layer, which is the following layer here, for which we'd like the pipes to follow. So this is that layer of polylines. We're going to use all the objects on the selected layer and click on Yes. Software goes ahead and creates a schematic layout of pits and pipes. Now what we'd like to do is now start to have these designed. So we're going to click on the Create Update Network button, tell it where the end of the system is, so it's this point down here. We're going to give this a name, and then we're going to click OK. Now we can begin to assign catchments and bypass and flows into these particular pits if we choose. You can see how they've been set up here. We can begin to also look at the vertical design of these particular pipes by clicking on the VGE button. We can then click on a particular pipe that we're interested in, click OK, and this will open up the vertical grading editor. And in actual fact you can actually see this, because this is the pit at the start of the system where we clicked, you can see the embankment there of our basin as we're going through. So this is our vertical grading editor for the pipes, and we can use it in similar fashion to how we used it for the roads. What we may do is just quickly change the vertical exaggeration here to say 2. In fact, let's make that 5, and begin to move things around. So we can right click on a pipe and begin to obtain design information about that particular pipe. We can also make changes to that pipe. So let's just say that pipe needs to be bigger. We can go ahead and select a different alternative diameter. So very quickly we can build up the design. In addition, we can then look to see these pipes in 3D, and to do this we might pop back to the Roads tab, click on Model Viewer. Now because we're using pipes here, we can simply use the transparency button down here, which will enable the design to be viewed with a transparency value, which is perfect for pipes. When we go to the Objects tab, we can say Pipe Networks. You can see we have a pipe network listed in there. We're going to say yes to display the pipe networks and simply click on Close. You'll see there's our larger pipe that we've just created. Let's go ahead and just make another change, maybe further up the system, maybe making this pipe a little bit bigger as well, and see what happens. We're going to go back to the Pipes tab, Vertical Grading Editor for the pipes. We're going to just, in the background, find that particular pit, click OK. We're going to right click on the pipe, and we're going to make it bigger. It's going to make it considerably bigger. See, there we go. Now we're going to close that down. And all we're going to do is come to the Home tab and refresh. You can see there how that pipe has been updated. So very, very useful way of being able to visually see what's going on with your design of your pipes relative to the rest of your design. Now unfortunately that's all the time I have to show you civil site design. However, over this very short time we have created obviously multiple design objects and hopefully highlighted some of the key areas where our civil infrastructure solution integrating with BricsCAD enables fast and efficient design and delivery of projects. Thank you for your attendance, and thank you also to Bricsys for giving us the opportunity to showcase civil site design. If you'd like more information, you can visit the Bricsys website. You can also have a look at our product website, which is civilsitedesign.com.
Thank you very much, Jonathan. For the next part of the session, I would like to introduce my colleague, Mr. Arvind Thunga. He will take us through BricsCAD Mechanical.
Wow, thank you for enlightening us. That was really informative. Good afternoon, everyone. My name is Arvind, and I'm a technical support analyst at Bricsys. Let me walk you through some of the new and exciting features in BricsCAD Mechanical V21. If you did not hear about BricsCAD Mechanical before, then you probably consider it as just another toolset to create 2D mechanical drawings. While 2D drafting is perfectly possible with BricsCAD, we at Bricsys strongly believe in 3D. Three-dimensional modeling allows designers to fix errors at early design stages, analyze different aspects of design products, generate NC code, and technical documentation. While BricsCAD Mechanical is not a toolset for 2D drafting, it is also not just another mainstream 3D mechanical CAD. There are serious differences of BricsCAD from other MCAD softwares. First of all, with BricsCAD, you don't need to spend your time and money to study a completely new software with its own GUI and design principles. With BricsCAD, you always remain in the same familiar environment, which was extended with few intuitive tools. Secondly, with BricsCAD Mechanical, you will be more productive in design thanks to our unique technology of 3D parametric components and hundreds of vertical applications from our partners. You can easily implement your own tool or application using our Lisp or BRX API. Third, BricsCAD does not pretend to replace your current CAD system. It is ready to collaborate in multi-CAD environment. You can continue to use your different CAD tools, but with BricsCAD, you will never have headache with file formats, which lose design intent in translation. I believe no other CAD system in the world has so powerful tool set to rework imported geometry using a combination of direct editing operations with automatic history-free parameterization. Each year, our quality assurance engineers test new functions of BricsCAD Mechanical on a completely new model. This year, we were inspired by the idea of Maltese cross mechanism. This is a gear mechanism that translates a continuous rotation of the driving wheel to an intermittent rotation of the driven wheel. It was modeled in BricsCAD using 3D constraints and expressions. And this movie was recorded in BricsCAD using Animation Editor, which allows you to create complex scenarios of 3D parametric animations with different effects, including appearance or disappearance of particular parts, kinematic simulation, and camera movement. As you can see, this Maltese cross mechanism is a subassembly of the filling and capping machine. Through a conveyor, the bottles are moved under some filling valves that inject the liquid into them. After the filling, the bottles move up to the other side of the machine where a cap is provided for each of them. This model also has parameters, which allows to adapt it to bottles of different size. It is a large assembly which consists of more than 3,000 parts, of which 500 parts are unique. And this machine is part of a brewery which also has a lot of vessels connected with pipes to a water supply and the machine. A number of standard parts are used here, which is also typical for many other industrial assemblies. This complex model was designed in BricsCAD Mechanical from scratch using new and improved tools available in version 21. This year, we implemented the most popular suggestions of our customers and partners and extended the main tool sets, which are sheet metal design, assembly design, and technical documentation with the most requested tools. Let's take a look at these new features with the help of this brewery model. There are a significant number of very useful new features in sheet metal this year. Let us take a look at the most powerful of them using two sub-assemblies of the capping machine. In order to demonstrate the new intelligent way to create sheet metal parts from simple solids, we will be using this control box. Let's convert them to sheet metal, and now for the bottom part, you can see that on clicking on the top face, bends, junctions and reliefs are created automatically at the same time. That's really wonderful. For the middle part, we just click on two faces, the back and the front, and everything is being automatically created. We just have to choose the kind of miter, which is very fast using the amazing propagate capability that looks for similar geometries and automatically applies the miter. In a matter of seconds, it is done and we can unfold the model. That is really amazing. Let's go now to the top part. First, we create the bends on the top face. You can see that the related junctions are automatically being created here. Then we repeat this on the two back faces. Everything is created automatically except for the miters, which again can be placed using the propagate capability, and it's just a matter of a single click. Now let's try creating the curved junctions on the bottom and on the top curved edges. We will be creating the junctions here. This looks really easy. We still need to make some minor changes to unfold this part. Thanks to the possibility to switch bends and junctions, we will be swapping the bends with the junctions on the two sides. Now we will be able to unfold the part. Another important new capability is the possibility to assign one body with its specific properties, despite the fact that we had converted all the parts together. Here, we are going to change the thickness of the bottom part. And you can see here the thickness is updated for the bottom part alone, and the rest of the components retain the original thickness. And now we will go ahead and unfold all the parts. You can realize that in less than 4 minutes we have converted the 3 solids into sheet metal, and we have also unfolded them. That is really amazing here. Next, we will be using this drum feature that distributes the caps that will be crimped on bottles to showcase some advanced features in sheet metal. We start from the shell state, what we call as poor sheet metal in BricsCAD language. First, we convert them to sheet metal. Now, we are going to add the bend to this small part that you see here. But you see there is a gap at the flange end. Now, we will be filling this gap using the sheet metal junction. Then, with our new T-tabs function, we can switch this junction to a tabs and slot inside the flange, and not only at the corner. Look at this result here, that's really amazing. But this is editable. We can change any parameter. For example, we can change the number of tabs to 2, and it is going to still retain the symmetrical feature. Now, we will add 2 small flanges to guarantee the perpendicularity. And let's try to fix the width to maintain the design intent. Let us see how the tabs are going to behave when we try to move them by moving the flange using the push-pull command. The tabs and slots are going to move accordingly, and the design intent is being maintained. Even when we try to rotate the flange, the tabs and slots are going to move correctly. Then, thanks to the new capability of BricsCAD 21, we can change the thickness of this part, and you can see that the tabs and slots are actually changed, and the design intent are also respected. And you can see there is no collision here. And of course, we can unfold this as well. Things get even better with this next capability. What about tabs on curves? First, let's set up a number of tabs to 0. It means that the number will be chosen automatically according to the distance that is being selected. Now just click on the round edge and let's see the miracle. We are going to get the tabs with the perfect distribution. Of course, we must create a junction to separate the parts, and let's do that here. And now to finish, just select the remaining parts in the rectangle and click on the create bend. These solids are now fully converted to components which can be successfully unfolded. Finally, we can go ahead and unfold all the parts. If needed, these drawings can be exported to DXF file format as well. All these features will help us to save a ton of time during the design process. But there is one more kind of part which is also very typical in the mechanical engineering. These are seamless and welded pipes, elbows, T's, crosses, reducers and flanges, also called as pipe fittings. They are widely used in machinery, automotive, aviation industries and also in oil and gas. In BricsCAD V21, we added a rich set of such parts of the most popular standards. We also streamlined the way to insert and connect them. The bottom-up design was never so easy, and we keep the freedom of direct editing in combination with full parametric control. Let's see this in action. I want to show you some cool new features and tools which we have prepared for piping design. Let's go ahead and showcase this with the brewery model, which was created from scratch in BricsCAD. As you can see, this model contains around 800 parts and more than 1000 constraints between them. All these constraints were added automatically and during the new mode of BM insert command, which is called the smart insert. Let's check that even with such a big number of constraints, this model is workable. For example, to have access to the vessels, we need to add a platform between them. The original platform looks very big, but fortunately it is parametric, so you can easily change its dimension to adapt to the actual situation. Here we need to change the height and the length. As you can see now, we have a problem. There are few intersections between the inserted platform and the existing pipe layout. We cannot change the platform since we want it to be as small as possible to save useful area. So we go ahead and change the pipe's layout. But actually, it's not a big problem. Since pipe layout is properly parameterized and we can just move it by manipulator or the move or the DM commands, and everything is going to move. For example, the placement or the pipe lengths will adapt automatically. So we need to move just one pipe and the whole line will move properly. There is still intersection with the valve, so let's move it also. Since our brewery has become bigger and bigger, workers will not have time to do everything manually. So we want to upgrade it by adding some automation. For example, by adding the filling line here. I think you remember this filling line. By sheet metal demo, we had used this filling line here. Here is our filling line and now it looks like everything is ready for connection. But we cannot directly connect the filling line with the layout. We need to add a pump. This pump will transfer the beer between the filling line and the vessels. We do not want to place the pump in front of the required flange because it will block the passage. So what we actually need is to place the pump behind the flange, but it again will cause of some modification of the existing layout for proper connection. So first what we do is we rotate the elbow with the flange. It can be done by any rotation command or just by manipulator. Such operations will preserve all required constraints. So layout still can be modified properly. Then we need to connect flange to the pump. We can just directly move it there or use the BM connect command, which was implemented to connect two components which have information about how they should be connected. As you can see, the outer diameter of the existing layout does not correspond to the pump diameter. But again, we have properly parameterized the layout, so we can adapt diameter by just changing one parameter. So flange, the adjacent pipe and all the other connected pipes and T's will change their diameter properly. Let's continue. Now we want to connect the pump to the filling line. We can do it easily with the help of a new standard parts library and a new option of BM insert command called Smart Insert. Standard parts library I have reconfigured to improve the usability. All existing parts are separated in three categories: fasteners, machine parts, and structural shapes. The category of piping with the 182 new parts are also added. Mostly it contains parts from the American standard, the German standard, and also the international standard, which is the ISO. Currently, piping categories include following parts like pipes, fittings, like elbows, returns, reducers and eccentric reducers, T's and crosses. A lot of different flanges as well. And finally, there are also the gaskets. So if we will drag a piping part from the library, by default the Smart Insert mode of the BM insert command will be used. This mode can be used on components which store inside information about how these components should be connected to each other. This information is stored as point and line on special layers with the postfix connection. These entities represent connection point and the connection direction. Also, this mode recognizes which parameters of the base component can be used in inserted component and try to copy values or expressions of such parameters. This allows inserted part to adapt to base 1 and also will allow to create parameterized layout. One more thing which allows to create parameterized layout is proper constraining. So Smart Insert analysis inserted and base parts and decides which constraints should be added to them to allow correct further working. We continue with the creation. As you can see, When you hover inserted parts to base 1, its size is being changed. It will properly connect to base 1. Moving and rotating of such parts is still available and does not spoil the parameterization. Moreover, because of constraints, adjacent elements are adapting to the move. Smart insert can be used not only from library but also on already inserted components. As a final step, we need to actually connect the created pipes to the filling line. Here, for that, we are going to again use the move command, but in that case, we need to position everything correctly. But we can also do so using the specialized BM connect command, which will do it automatically. You only need to point out which two components should be connected to each other, and you can see here using BricsCAD 21 it is possible to create the parameterized pipe layouts which can be easily changed if needed. We just saw that assembling large parametric pipe systems in BricsCAD Mechanical is as simple as connecting Lego parts together. But to manufacture these assemblies, one has to properly generate the corresponding technical documentations as well. Let's see how to solve this task with BricsCAD Mechanical. In V21, we implemented new powerful tools to create associative two-dimensional drawing views from 3D models of mechanical parts and assemblies. Let me demonstrate these tools to you on the example of the beer vessel. According to the standard, the main view for the vessel is the section view. To achieve this, first we should create the base views beyond the layout and then create the section of the side view. Also, we can create the top and the bottom view. They can be later on annotated. The next part of the vessel are the most important. They are responsible for preserving the contents of the vessel. The middle manhole sub-assembly does not completely fit into our drawing, but we can easily change their scales using the command option. The command option allows us easy customization during the view creation. The next step is not so obvious and could take some time because the sub-assembly orientation is not known. It is not aligned with the coordinated axis. That's why to create the correct view for the top manhole, we use the view base command with the current orientation option. This option inherits the camera position from the model space and uses it in the drawing view. It allows to create the custom view quickly and easily. The space on our layout is limited. We also plan to add annotation tables and technical notes in the future. In V21, we introduced the new break view command that can reduce the drawing view area by hiding the fragments. Let's create a vertical dimension and check how it behaves with the break view. Now you see the vertical dimension keeps the correct value after the break operation. The break symbol has several properties. You can change the type of the symbol. For example, you can change it from spline to zigzag. And other parameters such as distance between the curves can also be changed. We support vertical and horizontal cuts and can combine both on one view. Fixation of the manhole door is achieved by using a threaded pin and knob. We've implemented the new DM thread command which allows to create a decorative thread to display on the drawing view. Let's open the pin component and add the thread. Using the new tool, we can easily create the thread on any cylindrical face. You can configure the pitch, the length and the diameter of the thread. Let's switch to the main assembly and create a drawing view of the pin. You can see that the threaded model displays correctly in the drawing views. We put all the necessary views on the drawing. It will be finished later. Now I propose to switch to another drawing, a very special one. Our project partners helped us with a couple of drawings, but they have preferred to work on an old style manner using AutoCAD Mechanical. Unfortunately, after receiving the drawings, we noticed several mistakes that must be corrected. By default, when you open an AutoCAD Mechanical drawing, some specific symbols represented as proxy objects. To be able to apply changes to these objects, you need to activate the Mechanical 2D enabler like what we have done just now and reopen the file. After that, you can modify the 2D elements. We are supporting copy, move, erase and other basic operations. but our capabilities are even wider. For example, you can see here the datum ID is being copied using the manipulator. In V21, we added the ability to change the properties for 2D elements from the property panel. We've corrected the feature control frame properties and now replacing the surface finish symbol. Another example illustrates the assembly drawing. It allows us to demonstrate the ability to change the balloon properties such as the balloon type. You can change it from circular to polygonal and arrowhead style. In our case, we use a standard arrow. We see that the part list overlaps by other balloons. So we have to correct this mistake and at the same time edit the support bracket material. All these manipulations will take us just a few seconds, and we did not ask the author for this document for any help. The next step in documentation in most mechanical drawings are tables. It can be a trivial part list or something more sophisticated. Bill of Material Manager of BricsCAD Mechanical allows you to create many kinds of such tables, and since V21, its capabilities became absolutely fantastic. I'm going to show you the most interesting features of Bill of Materials in BricsCAD V21. Let's start with this brewery model. With more than 3000 parts here, you will need a fast, flexible and powerful tool to document and analyze. Good news is that the Bill of Material in BricsCAD does exactly that. For example, what if you want to see only the parts related to pipes, which this model has a lot? To list only the parts related to the pipes, we will add the part category column and use a new feature of BricsCAD V21 called column filters. Column filters allow you to quickly set criteria to show the rows which we need, similarly to the spreadsheet processors. Here, we use the filter to select only the part categories related to pipes such as the elbows, flanges, pipes, reducers and tees. This table now shows all the parts related to the pipes. But what if you want to know the total length of the pipe by the size? To find out, we copy this table and adjust the filter to show only the pipes. Next, we remove the component column and add the size and length properties. Normally, BricsCAD groups parts with respect to their components. In order to group pipes by the size only, we need to change the grouping mode to by columns only. In this mode, parts will be grouped only by the added columns, which is exactly what we need. To get the total length for each pipe size, we use another new feature called the aggregated function. Similar to the footers, they can also compute the sum, average, minimal or maximum value in the group. And you can still add them to the footer. Additionally, you can also set a column filter to find a specific range. Let's say in this particular project, I want to see only pipes between 50 and 100 meters long. This can be easily done using the aggregate function. Aggregate function and the column filters form quite a powerful tool, and we hope you liked it. Now, let me switch to a familiar drawing of the maturating vessel. It's almost ready now, and all we need to do is to add some specifications and annotations. Let's start with the material list. First, we create a bottom level bill of material and rename all columns to meet the company standard. For pressure vessels, materials and dimensions for each part are also required. So, we add the necessary columns such as the physical material, the part category, the part number and the length. However, we want dimensions to be in one single column. So we create a template column from the selected ones. It's a new feature to combine several properties in one cell. It's based on the so-called D-cell expressions. So even quite complex templates with conditions are possible. BricsCAD automatically adds delimiters between values, which you can adjust with your own text. Of course, you can configure template columns as you want using this template configurator dialog. Now all we need to do is to remove no longer necessary columns and add the table to the drawing. And now it's done. Isn't it impressive? Of course, we've highlighted only the most spectacular new features of the bill of material, but there are more. Please try them using the BricsCAD 21. Those were some of the new and exciting features in BricsCAD Mechanical V21. Our development team has already started to work on the implementation of new mechanical features, which will be released in V22 or during V21 release cycle. So please don't forget to send us your feature requests. We listen to them very carefully. And now, let me invite Claire again to showcase some of the exciting features in Bricsys 24/7.
Hello, and again, I'm Claire. As the APAC technical consultant who focuses on our cloud solutions, I would like to give you a bit more insight to our Bricsys Common Data environment. Aside from our all-in-one CAD solution, BricsCAD, Bricsys has also developed over the years a robust, secure, and easy-to-use cloud platform for collaboration. We currently have two solutions. The first is Bricsys 24/7. Bricsys 24/7 is used as a common data environment with the purpose of managing documents in and around AEC projects. The second, BricsCAD Cloud, is a BricsCAD-only product that is used for managing drawings from within BricsCAD. The Bricsys Common Data Environment solution is built around 5 key elements. The first and most important one is, of course, managing documents and drawings. You can easily upload and download files. There's an automated version control system, which allows you to go back and consult older revisions. Aside from a detailed activity log, powerful search capabilities, and automated notifications, a check-in and check-out mechanism is also available. So while you are working on your document, no one else can change it. You can also add any kind of information to your documents through configurable metadata. For example, adding an internal reference text so you can easily use the search filter to find it. Second, you can share all kinds of files and view 70 plus file types online, including DWG. You can also make remarks and have a choice to notify the whole project team or only certain project members about important comments on your drawing. When working with different team members, you want to make sure that the right data is in the right hands. On our cloud solution, you can easily set access rights for different user groups, or what we call roles. This is done intuitively, as the interface of each user is customized according to his access rights, meaning a user sees only the folders and action icons that are relevant to him. On our cloud platform, you can also easily set up configurable workflows. This way you can automate processes, such as assigning tasks, distributing documents, and processing approvals. With the graphical workflow editor, you can easily set up a workflow to automate document distribution, assigning tasks, document approvals, and notifications. Let's now see how an automated task and an approval workflow works in Bricsys 24/7. In this case, let's say you are Kin, an architect involved in the Sky Office project. Once a task is assigned to you, you will receive an email notification where you can click on the link to respond. This will immediately bring you to your online project task. You can see the task itself, what question there is for you, as well as check out other information that is involved in this task. You can also look into the viewer, wherein you will see the drawing without having to download it. In this case, this is probably a DWG drawing. It includes any sheets or layout, as you see on the lower left side, and on the right side, you can also see annotations that are already there. You can also add to these annotations by adding an annotation. Let's say you want to say okay, but would like to change colors. You can choose to make this annotation public. You can add more description. You can add an annotation. And once done, you can click OK. And you will see that annotation already on the annotations list. You can also choose to use the arrow annotation, and also printing to PDF gives you the option on choosing what information to print. So let's say you're done with making comments. We will see that closing this dialog will bring us to the automated workflow where this task was assigned to you. Actions in green are done, red is for your action, yellow is pending action by other roles, in this case the designer. Now you can approve this, maybe add a further comment to review the annotation that you added earlier on. And once you're done, you will see that the action that you completed just now has been changed to green, signifying that it is done. You may also choose to add a form to be filled out with metadata. Let's say you want to have a form for cost approval by a project director. Let's add a form now and see that we can rename this and have a title, approval by project director, maybe costing approval, and drag in the fields that we want. Let's have date, drag in a number field to put cost approval number, text for title, another text, perhaps longer one for description and reason for the cost approval. And then let's actually also put some choices. They need to check one of these choices, and then we can also add in a cost field. Of course, this is a cost approval, we'll need that. And once done, you will see that this costing approval form is now in our list. Finally, let's talk about the last key element, the fifth one. So last but not the least is the possibility to perform actions outside the web interface. For this, we have a mobile app, transfer tool, the BricsCAD built-in panel, and integrations that are possible using our REST API. So with the mobile app, you can access, view, and mark up drawings, whether you're at the office or maybe on the field. With the transfer tool, it's a small desktop application that makes it possible to easily upload and download documents from or to the cloud. You can also drag and drop files and even full file structures to and from your online projects. We also have the Bricsys 24/7 panel, which is built into BricsCAD, which gives you immediate access to download your drawing, work on it, and upload it back to your online project without even having to leave the BricsCAD platform. Let's see how the built-in Bricsys 24/7 panel is integrated into BricsCAD to improve your productivity. On the right side, you will see a Bricsys 24/7 panel. It is the cloud icon there, and you can log in, put in your Bricsys account credentials, choose your project, and find your file within the folder structure, download it, work on it. You can also lock it to make sure that no one else can change it while you are editing. And then you can go back and upload it back to the online project that you have. You can also add in some descriptions or comments to what you have changed. And once uploaded, you will see that now it is up to date in your online platform. So those are the 5 key elements around which the Bricsys Common Data Environment was built. So let's see the two Bricsys Common Data Environments again, Bricsys 24/7 and BricsCAD Cloud. And here we will see the main differences between these two solutions. So when choosing which option is appropriate, it really is up to the company or project needs. If a certain company or project has a need for customized metadata, workflow automation, BIM model manager, some detailed reports probably, as well as no need to worry about the number of users in the project, Bricsys 24/7 will definitely be more appropriate for that. Now let's look at what we can look forward to Bricsys 24/7 in the future. We look at these 3 main pillars for the future of Bricsys 24/7. First, build further on our strengths. Second is interoperability. And third is cloud diversification. Let's talk about building on our strength. This will be focused on the ease of use of Bricsys 24/7. This is a very important aspect in which Bricsys 24/7 already does very well. Hence, we want to enhance this even more. And this is why we are building our new user interface. We will also expand further on the workflow functionality. It is already powerful to use the current Bricsys 24/7 workflows for your projects, from work in progress phase to sharing documentation with a broader team, moving to construction, and at the end onto the as-built phase. And of course, we will improve our viewer technology in order to provide you with more actionable features to drawings that you store, such as maybe taking quick measurements from your drawings without even having to download them. Now, let's talk about interoperability. We recognize that it's important that we integrate with other solutions to enhance your experience. For example, looking internally within the Hexagon group, of which Bricsys is part, we have Ecosys that provides very strong construction management. We have built a really strong integration where our clients can manage their project in Ecosys while managing documentation in Bricsys 24/7 in a seamless way. Beyond the Hexagon family, we are looking into further integrations with best-in-class third parties, such as those for issue management, which a lot of our clients are actually already using. In this way, it will be more advantageous for our clients. We are also enhancing our API to make it easier for third-party developers to integrate and further improve the experience for the users. And lastly, which is the third one, onto diversification. The team is working closely with the BricsCAD BIM team for a multi-user environment. Also, we are looking into virtual reality, which we have already done a proof of concept with one of our clients. It is fully operational and functioning, and we are looking to scale that. Another aspect for cloud diversification is offering libraries where you can store elements which may be your company standards, authorized to be used for certain projects. So those are the three pillars as we can see here. One, building our strengths with ease of use. The second, interoperability by integrating with others. And lastly, diversifying our offerings. We hope this gives a bit of idea on the future of Bricsys 24/7. Thank you for listening and thank you for staying. Thank you everyone for staying on. We hope you enjoyed the session and that you gained knowledge that you can use for the developments in Australia and New Zealand. If you have any questions or comments, please don't hesitate to reach out to us. We look forward to hearing from you. Have a great day ahead.